Alright, today's lesson is I can set up and solve inequality word problems. So let's take a look at this. There are some key words to look out for inside an inequality word problem. These are the words that tell you that this problem is probably an inequality problem. If the words are at least, at most, more than, or less than are inside the word problem, that's a good indicator that this is going to be an inequality type of problem. So let's take a look at one. Keith has $500 in his savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of the summer. He withdraws, takes out $25 a week for his cell phone bill. How many weeks will Keith have at least $200 in his savings account after summer? So here, the words at least tell us that this is going to be an inequality problem. He says he wants at least $200. So can he have $200 at the end of the summer and be okay with that? Yes, because he wants at least that amount. He doesn't want more than, he wants at least that amount. So this is going to be a less than or equal to problem. So, or it's going to be greater than or equal to problem. So it says he has $500 at the beginning. He wants at least $200 at the end. So at the end, he wants at least $200. But he wants at least that or more. So this part over here has to be more than or equal to. He starts off with $500. So after the beginning of summer, beginning of summer. So he has $500, and each week he takes out $25. So we're going to represent that by minusing 25W. So this will tell us how many weeks he can go into the summer before getting down to $200. So to solve this, we're going to subtract 500 from both sides. We get negative 25W is greater than or equal to negative 300. And divide both sides by negative 25, which means we're going to flip the sign. And W is greater than or equal to, this is going to be, or less than or equal to 12. So you can go up to 12 weeks before reaching the $200 mark. Let's take a look at another one. Yellow cab taxi charges $1.75 flat rate in addition to a 0.65 per mile. Katie has no more than $10 to spend on the ride. Rate inequality that represents Katie's situation. So here, she only has $10. And she can only spend as much as $10. So $10 is going to be on one side. She has to spend at most $10. I'm going to write that as 10. Oops, excuse me, the last one, the answer was 12 weeks. That's our final answer. So, here, she can only spend $10. And it has to, what she is actually charged for has to be less than or equal to $10 because she can't spend any more than that. So we have $1.75 flat rate. That's the money that she has to pay no matter how far she goes, and then she has to pay a little bit more each time she goes a mile. In fact, it's 0.65. Every time she goes a mile, and X represents how many miles she goes, because that's what we don't know. Okay. So this represents her situation. So if we were to solve this, we would have to subtract $1.75 from both sides. We get 0.65. X is less than or equal to 8.25. After that, you have to divide by 0.65. Because this is a positive number, we do not need to divide or excuse me, we do not need to change the direction of the sign. And so we have 8.25 divided by 0.65. We have x is less than or equal to 12.69, approximately rounded to the hundredths place. So you can only go about 12 miles, a little bit more than 12 miles on this taxi ride. Okay. So, we'll go another one. Chris wants to order t-shirts over the internet. Each t-shirt costs $15.99, and shopping for the entire order is $9.99. Shipping fee is for the entire order is $9.99. Chris has no more than $100 to spend. Could he spend $100? Yes, he absolutely could. He doesn't. He just doesn't have enough money to spend more than that. So again, the word "no more than" or "more than" is in here, indicating this is going to be an inequality problem. Okay. So, how many t-shirts can Chris order without exceeding his $100 limit? So he can spend $100, but he has to spend less than or equal to $100. And we know that we have a flat cost of the shipping fee, which is $9.99. Each t-shirt costs an additional $15.99 per t-shirt, and X is going to represent how many t-shirts he can buy. So to solve this, we do 100 minus 9.99, we get 15.99. X is less than or equal to 90.01. We can divide both sides by 15.99. We get X is less than or equal to 5.63. We'll round it to the hundredths place. Now, we have to think about this a little bit logically. You can't buy 0.63 of a t-shirt. Okay? So therefore, the most that he could actually buy is the most he can buy is 5 t-shirts. Okay. The most he can buy is 5 t-shirts because we're not going to buy 5.5 t-shirts. We're not going to buy 5 1/10 t-shirt. Going back to this question, I apologize. I didn't use units. Bad, Mr. Juan. The most he can go, she can go is 12.69 miles. Okay. The last one, Scaitlin charges a $50 flat fee for a birthday party rental and $5.50 per person. Joanne wants to spend less than $100 on the party. How many people can Joanne invite to her birthday party without exceeding her limit? So the words "less than" are in the problem. So therefore, this is going to be inequalities problem. Can she spend $100? In this case, no, because it says less than, not she can spend up to. Okay, so. In this case, she wants to spend less than $100, so we're going to represent that by this. This is over here going to be how much she spends. So, again, she has a $50 flat fee. So she has to spend $50 plus $5.50 per person. X will be the number of people she can bring. To solve this, we're going to subtract 50 from both sides. We get 550x is less than 50. Then we're going to divide both sides by 550. What we get is 9x is less than, we do it up here, x is less than 9.09. Now, obviously, she is not going to bring 0.9 of a person or 900th of a person. So therefore, our final answer is going to be she can bring 9 people. Okay. She can bring 9 people to the party without exceeding her $100 limit. Go ahead and try the rest of the problems on your own.